Okay, so specifically, this is just me reminding you because we've talked about these things already. Rational numbers are anything you can write as a fraction. So numbers that can be represented by A over B are called, oh, whoa, what happened there, buddy? Yikes. Okay. Are called rational numbers. Even if they are decimals, like 0.5, we can still represent 0.5 as a fraction, which is half. What about 0.3 repeating? Does anybody know what that is as a fraction? Yeah, 1/3. So even if it is represented as a decimal, some decimals we can also write as fractions. So they are still considered rational. Numbers that we can't write as fractions are called the opposite, irrational. Most of the irrationals that we'll talk about are pi or some sort of square root that is not perfect. So like this square root of 15. Nobody is, you are so right about that. Square root of 15 is not perfect because I can't think of a whole number times itself that gives me 15. But an opposite example would be like the square root of 36. Square root of 36 is perfect because what number times itself gives you 36? 6. 6 is rational. So some don't just say because it's a square root, it's irrational. That's not true. It specifically has to be a square root that's not perfect for it to be irrational. So we want to look at this chart and we want to decide, are these numbers rational or irrational? So square root of 9. It is rational because what is the square root of 9? 3. 3 is the square root of 9. It's perfect. We call it rational. Square root of 8. Irrational. Now I did have someone in third period say rational because they said it's 4. The square root does not mean divide by 2. Square root means what number times itself gives you that number. So I just want to make that clear. It is irrational. Pi, I hope you know by this point, is irrational. Does anybody know or recognize that fraction? Okay, let's talk about that. So Thorne said that 22 over 7 is pi represented as a fraction. But didn't we just say that you can't write irrational numbers as fractions? Okay, so I'm going to say that 22 over 7 is a squiggly equal sign, which what does a squiggly equal sign mean? It doesn't. Does anybody know what a squiggle equal sign means?
Isn't it like around?
Yeah, like around that number. So when your teacher probably last year in 5th grade said that to use 22 over 7 for pi, they're not wrong, but they're not giving you an exact, it's an estimation for pi. 22 over 7 is 3.142857. Pi is 3.1415926535, blah, blah, blah. So 22 over 7, although used a lot to approximate pi, is still rational. It's not exactly equal to pi. So I just want to make that clear. 9.48 repeating is rational. FYI, 0.48 repeating as a fraction is 48 over 99, in case you wanted to know. 33 over 2 is obviously a fraction, so that would be rational. 2.23606 would be irrational because it is a decimal that does not seem to repeat and it doesn't stop. It has those ellipses that tell me that it goes on forever. And negative 25 is rational. Okay, so let's come up with some rules here. I want you to add 1/6 plus 2/9. I'll give you a second to do that. Add 1/6 and 2/9. Didn't think you were adding fractions today, did you?
I never did this in like since fourth grade.
It's been a while. I'm sorry. I'm only gonna have you do it once, so. You okay over there? Yeah. Okay. I just burped and hiccuped at the same time.
Who does it? That's like a fun thing. A lot for me.
Please, please, I beg of you, please don't write 3/15.
Yes.
When you're adding fractions, you need to have a common denominator. You could have done 54, but there's a better one. 18.
Why did 36?
Or 36, yeah, or 36. I just said 54 because 6 times 9 is 54. So 18, 6 times 3 gives you 18. So we want 3/18 as an equivalent fraction. 9 times 2 is 18. 2 times 2 would be 4 as an equivalent fraction. Yes, Kylie, it was 7/18. So I wasn't just doing that because I wanted to see you add fractions. The point here is when you add a rational number plus another rational number, ooh, I can't spell, rational, that's not right. Yeah, it is. Your answer is always going to be a rational number. There is no situation where you add two things that are rational and you get something that is irrational. It's impossible. Not going to happen. The same thing goes for multiplication. So I want you to multiply 3/7 times 4/9. This one's easier. Easier. I don't think you can simplify this one. It should just stay as 12/63, 12/63. So the same thing happens when you multiply rational times another rational. You are always going to get something that is rational. Oh yeah, you're right. I can't simplify, can I, Renee? It does simplify. Divided by 3. 4/21.
Oh,
Yeah, good job.
see that.
Me either.
Why does it feel like it's 7 a.m.?
I don't know. I feel like it's like,
7 p.m.
oh yeah, I was gonna say, I feel like it's like not my bedtime, 9:15. Yes, I still have a bedtime. I know.
My bedtime is 9.
I have a bedtime so that when you guys see me right now, I'm not grumpy. Because if I didn't get my 8 hours of sleep, I would be grumpy. Oh dang, I'm jealous. So now we're going to talk about another situation. What happens when I add a rational and an irrational? So let's say I add 2 plus pi. Okay, so let's think about this. Pi is 3.141592, blah, blah, blah. So plus 2 would be 5.1415, ... So we have a rational and we are adding irrational. What kind of answer did I get? Sam? So the last thing we said was if we add a rational and irrational, we're going to get an irrational. Same thing goes with if we multiply a rational and irrational. So like 2 times pi. And I'll tell you what that is. Where's my pi button?
6.28.
2 times pi is something like 6.28. Why doesn't my calculator have a pi? Where? Ooh, great question. Who created pi? Pi was not just made up. Some dude isn't somewhere just being like, I feel like pi should be this. Pi is the exact number you get when you take any circle in the whole wide world's circumference and divide it by its diameter. That is, yeah, I hope you learned it last year, maybe, possibly. It doesn't matter how big, doesn't matter how small. A perfect circle, if you take the measure of the outside, the circumference, and divide it by the measure across the diameter, you will get 3.141592653. That's all I know. Not an oval. Perfect circle. Good question.
When's the last time I said oval?
Right now.
I know.
So moral of the story, rational times irrational is going to equal irrational. Okay, so we're gonna do this first one together and then I'm gonna have you do the try it. So we have on the let's practice 2 plus the square root of 3. So is that a sum or a product? It's a sum. 2 is a rational number. Square root of 3 is an irrational number. If I add those together, I'm going to get an irrational. So take a second to do the try it. So look at the 2 numbers, decide if it's sum or product. Tell me what kind of numbers they are and what your answer would be if you solved it. Don't solve it, but if you were to solve it, what kind of answer would you get? Okay, so we have 7 times a third. So times refers to product. Both of those numbers are rational, so that means our answer is going to be rational. Okay, you should have like a blank area under there. We're going to write one little side note. When we did properties like distributive, associative, commutative, identity, and inverse, does anybody remember the property that I skipped? I did skip one.
Starts with a C.
It does start with a C.
Is it CL?
It is CL. Closure, yeah. I don't know if you remembered or you just like pulled that out of somewhere. The closure property. So this is where the closure property matters. So underneath this you should have like blank space underneath there. I want you to write closure property. Is. So closure property means, like, let's talk about natural numbers first. So we're going to talk about natural numbers. So someone give me a natural number. 2. We're going to add another natural number. 3. What answer do I get?
5.
Okay. So can anybody think of a situation where if I add 2 naturals, I will not get an answer that's natural? There isn't. And since there isn't, this is called closed. It's called closed because whatever type of numbers I started with, I will always get that type of number as my answer. Let me repeat that. I started with 2 naturals. My answer is natural when I add them. Always. There is no counter example. Does anybody know what I mean by counter example? Mhm. Like an example that says that it's not true, or gives an example that says that goes against that statement. So what about subtraction? Is this true for subtraction?
No.
Okay, so give me a counter example.
10
Yeah.
minus 11.
10 minus 11. That would give me -1. So I would consider this not closed. The reason why is I started with 2 naturals. My answer is not always going to be natural. Okay. What about multiplication? Yes.
Wouldn't it like always have to be closed? You can't start with an integer.
For multiplication?
Yeah.
Yes, yeah. Multiplication's always going to be closed. And I'll give an example of like 3 times 6 would be 18. There's no example because we have to start with 2 positive whole numbers. My answer is always going to be some sort of positive whole number. So this would be considered closed. What about division? Can you think of a counter? So that's what I was trying to do. Try and think of an example that would give you not a natural number. Yeah.
If you like did something, you got a decimal.
Okay, so can you give me an example of that?
So
2 divided by 4. That would be 0.5, 5/10, 1/2. All that I care about is that's not a natural number, right? So we are saying that this is not closed. Now, this doesn't just go for natural. We could do this using integers. We could do this using whole numbers. We would just have to go through the operations and decide, do I have a counterexample? Is this going to be true all the time? So I just wanted to make sure that y'all realize what closed means. Closed means I get the same exact type of numbers that I started with. That's what closed is. All right, let's do the beat the test and then we'll take a break. So the beat the test says I have 3 numbers, A, B, and C. So let's make up examples. A has to be rational. Give me a rational number. 1. B is rational. 2. Wow. Big thinkers here. C is irrational. Pi. We want to go through these situations and we want to say, is it going to give me a rational number or an irrational number? So A plus B. 1 plus 2 would give me an answer that's rational. A minus C. Irrational. It would be, oh, I don't know why I checked rational. It would be irrational. A times B. Rational. A divided by B. Look closer. 1 divided by 2 is 1/2. That's still rational, right? Still rational. If I multiply all 3 of them together, irrational.
It's always a right, wrong.
Always?
Not always.
Okay. Okay, so here's what I want you to do. I want you to answer number 2. Digital students, if you can send me your answer to number 2 in the chat. I will paraphrase what number 2 is asking. If I multiply 2 numbers and my answer is irrational, tell me what you must know about 1 or 2 of the numbers you multiplied together. So I'll repeat that. Your answer is irrational. So what has to be true about 1 or both of the numbers that you multiplied together? Okay, so there's actually 2 situations this could be true in. 1 is that both of them are irrational. 2 is that At least, okay, so one of them is irrational. So at least one, if not both, have to be irrational for your answer to be irrational. Okay, great.